Yes, last class period, we talked about 6 different types of reactions. We talked about single replacement, double synthesis, decomposition, combustion, acid-base, as well as precipitation reaction. And then we group those 6 types under 2 major categories. We said acid-base and precipitation reactions are both referred to as double replacement reactions because you have 2 compounds on both sides of the equation. And the other 4, synthesis, decomposition, single replacement, as well as combustion, we refer to them as redox reaction, which is oxidation reduction reaction. Now, in redox reaction, electrons are lost and gained. That's why they are called redox reaction, because during the reaction, one or more elements will be losing electrons, while the other ones will be gaining electrons. Okay? And obviously we know that it's metals that lose electrons and not metals gain electrons. So, but today we focusing strictly on single replacement. Now, at the end of this lesson, I expect you all to be able to use the activity series to determine or to predict if a chemical reaction will take place. Now, the essential question at the end that you should be able to answer is, how do you use the activity series to determine if a chemical reaction will take place? If you're able to answer that question, that means you got a concept that we're trying to teach today. Now, a very short, brief background into single replacement here. Now, this is a silver cup. When you first bought this, it looks so shiny, everything so beautiful. But after a while, if you leave it outside for a while, the silver atoms begins to react with the hydrogen sulfide in the atmosphere. And then we know that hydrogen sulfide is a compound. Let me illustrate that here, in a sense that here I will have I have silver, which is Ag. It's an element. When it combines with hydrogen sulfide, which is H2S, it's a gas. But when it combines when it's in the atmosphere with the water vapor, it becomes acidic. And then when silver reacts with this, what happens is that the silver, this case, the silver will replace hydrogen. Now, at the end of the day, you're going to have silver sulfide. So I'm going to put a 2 right there. Plus hydrogen gas. So hydrogen gas is released. So that's what happens during that reaction. So in this case, you can see that silver replaces hydrogen. That is why it's referred to as a single replacement reaction, because one element, in this case silver, will replace another element in a compound, so in this case hydrogen. This is the reaction that is happening here. That's why this guy is looking so ugly, because on the surface of this cup, all those black and brown stuff, they're all as silver sulfide due to the single replacement reaction that is taking place. Now, things like this, if you're able to use the activity series to determine if reaction like this will occur. Now, what is the activity series? You guys can go ahead and complete this later. Now, what is the activity series? The activity series is simply the arrangement of elements based on their reactivity. So in this case, you see there are some of those metals, they are arranged in decreasing reactivity. As you go from top to bottom, the elements become less active or becomes less reactive. what it means is that the element on top is more reactive than the one below it. So which means that in a given reaction, any element that is above in its activity series can replace the elements beneath it in the activity series. Now, there's two examples here. You can see right here, magnesium combines with reacting with copper nitrate to give you copper plus magnesium nitrate. Now, magnesium is more reactive than copper because magnesium is high in the activity series than copper. You can see right here, magnesium is up here and copper is below. Therefore, magnesium can replace copper in this compound to give you magnesium nitrate, and then copper will not be by itself. Now, when you compare it to the second reaction, you could see gold reacting with hydrochloric acid. So what it means is that if you pour hydrochloric acid in gold, nothing is going to happen. Why? Because gold is at the bottom of hydrogen in the activity series. So if you have a jewelry all gold and your little sister has a bottle of acid and threatens you, oh yeah, I'm going to pour it on your gold and mess it up. Because you're a chemist student, you won't feel bothered because you know that nothing's going to happen. Because no matter how much it pours into your gold jewelry, it's not going to mess it up. Okay? So that is what the activity series helps you to determine. Helps you to determine if a reaction will occur. Okay? Now, here in the activity series, hydrogen is part of the metals because hydrogen behaves like a metal. It's in group 1, although it's a non-metal, but most reaction, it gives away electrons, valence electrons. That is why it's a part of the activity series for metals. Now, on the other end, the small part here, second part, is the activity series of non-metals. Similar to metals, the non-metals are arranged in order of decreasing reactivity. Most of these elements in the non-metal activity series are halogens, which is group 17. They are the most reactive non-metals. So it decreases from fluorine all the way down to iodine, and then you have sulfur and phosphorus. Example of this is sodium bromide plus fluorine. Because fluorine is high in the activity series than bromine, fluorine can replace bromine. Take note here, fluorine is replacing bromine, not replacing sodium, because it's going to be like to like. Non-metals with non-metals. Metals replacing metals. Okay, so in this case, we are comparing two non-metals, fluorine and bromine, based on their position in the activity series. Now, if you see here, bromine cannot replace chlorine because chlorine is high in the activity series. So if this F2 was Cl2 chlorine, the reaction will not occur because the reaction will occur because chlorine is higher than bromine. But if it was iodine, iodine cannot replace bromine because iodine is below bromine in the activity series. That's all I want you to be able to do, being able to use the activity series to predict if a reaction will occur, and then you complete the equation, which might be a challenging part, but once you get a hang of it, you will be fine. Now you can watch this video later once I'm done with this brief introduction. And let's look at one or two examples here. Predicting with metal activity series. Now, what I want you guys to do on this activity is use this activity series to complete this drag and drop problems. Now, if we look at the first one, let's look at the first one together. Zinc reacting with copper sulfate. Now, you're going to compare zinc to copper. Always compare it to the first element in the compound. So zinc in the activity series is up here, and the copper is below. Is the reaction going to occur? Jonathan, do you think it's going to occur? Now, zinc is up and copper is below. Which one is more reactive? Is it zinc or copper? Now, if you see this arrow, it says most reactive and then least reactive. As you go from top to bottom, it becomes less reactive. So whichever one is on top is more reactive than the one below it. So zinc, is zinc above copper or below? Is it? Good. So which one is more reactive? Perfect. So zinc is more reactive than copper. Therefore, do you think this is going to happen? Will this reaction occur? Yes, it will. Thank you. It will. Because zinc can replace copper. So now give you zinc sulfate, and then copper will be by itself. So that's why I'm going to drag this into that spot right there. So if you check it, you're going to say that it's correct because it's a valid reaction. Now, if for example, this second part, copper, can copper replace zinc? No, exactly. Why not? Good. It's less reactive. Perfect. So in this case, it's going to be no reaction because nothing's going to happen. Okay? So that's what I want you guys to use to complete that. And then the next one is the same thing, but in this case, this is simply non-metals. So in this case, we're going to be comparing the non-metals to the non-metal. So we're not comparing, for example, we're not comparing chlorine to sodium because sodium is a metal and chlorine is a non-metal. We are comparing chlorine to bromine. They're comparing to the non-metal part of it. So in this case, if let's look at this first one together. Now, if you look at this first one here, chlorine is here, second in the activity series. Bromine is right here. So which one is more active? Perfect, chlorine. Now, can chlorine replace bromine? Yes, good. So in this case, bromine will be by itself, and the sodium will go with chlorine. So what you will end up having is sodium chloride right there. Okay? So that's all I want you to do here, just to check which one is more active and which one is least. And then use it to complete that. And I think that is, I don't think there's a quiz or check for understanding on this in this lesson, but in the next one you might have. So that's all I want you to do here. And then once you're done with this, you click on next. You have the gizmos activity. Okay, so those ones one of them is very short, but the other one takes some kind of application of chemical changes and your understanding of chemical reactions to complete it. It's more like an investigative problem that you guys will do. And that is all I have on this on today's lesson. Question from me, Elizabeth? Jonathan, you have a question for me? Okay, number 9. Okay, good. I will